right, welcome to our science. The next one's the one we're going to use, I'd say probably the least when we're doing these cross sections. It's a very important rule when it comes to saying, if you're going to ask, which is an important question to ask, how do we know all this? This rule is critical. If we, I don't know what we're going to do for the correlation lab. Possibly not do it at all this COVID year. Because it's just one that I can't really picture right now how to do online. But what it is called, what it is a way to say that like rock layers that have had some of their contents, some of their stuff removed across a gap are probably the same rock layer. Like if layer C here has the same sediment, the same thickness, maybe the same index fossils, a lot of the same characteristics, chemistry, things like that, and you find it on one side of a gap and on the other side of a gap, that was the same layer. Now across, like if you've ever seen a picture of the Grand Canyon, it's fairly obvious, and it's not that difficult to picture that, okay, that was a rock layer, and then that river eroded out this big V-shaped valley, but that really was one rock layer, right? Where this is very valuable, and I'll bring it up when we get to that lab or lesson, I'm not sure, again, exactly what that will look like. Where it's valuable is saying, hey, if we can match that here, like, hey, I can find this rock just south of Syracuse, and then I go over towards the Finger Lakes and see another section where the Finger Lake is cut and I can see some rock, but I can match this with this, and then from the Finger Lakes, go somewhere down towards Pennsylvania and really correlate these over a very large distance. That's how we're going to get a more complete picture of geology. Any one rock cut you can see, like the Salmon River here in town, is a very short chunk of the story. Even if it's a big, huge cliff and you see a lot of rock, there's a lot more below it, and there probably was a lot more above it. That little tiny book, the bit that we're seeing, it's like seeing a couple pages out of a huge book, you know. Reading 3 pages of Moby Dick doesn't let you know the whole story. But if you can take that page, connect it with that page in another place, and then get a few more before it, and then connect that somewhere else, you can end up building the whole entire book. And sedimentary rock layers are like a book that shows us the history, the recent history of Earth's planet. So, enough babbling. We're not really going to use this rule a whole lot in this lesson, but it's out there. And it is called lateral continuity. Close one, right? Continuity. Looks right. Matching sedimentary layers across a gap were probably originally continuous, really, right? Or like same. Let's say that. All right. I think we'll call it good with that. And again, if we make it to the correlation lab with some form online, then we'll bring this back up. But for doing these, that guy really won't pop up a ton. All right. Either way, I appreciate you sticking with it. Good job. Keep it up.